Hi there, in this video we'll be learning how to find out the missing length or the missing angle of a right angle triangle. So to begin with, first I'm going to draw the right angle triangles, and this is the right angle triangle because one of the angle is making a 90-degree. Because we have to find out the missing length or the angle of this right angle triangle, for this we use a SOHCAHTOA. So we are using a trigonometry. So I'm going to write it down that we are using a trigonometry, and to find out the missing lengths we are using a SOHCAHTOA. I'm going to draw now 3 triangles. So the first one is for the SO. Then the next one is for car. I'm sure you all are familiar with SOHCAHTOA. So if not, I'm explaining you this here now. So now what's O and H represents for? So first of all, I'm going to draw the right angle triangle. Let's say if this is the angle X, whatever is opposite to the angle X, that would be the opposite. The other side of the right angle triangle, remember, it's the adjacent. So this is the opposite, the other one is the opposite. We know that the length which is opposite to the 90-degree is the longest side of a right angle triangle, and the name for that is a hypotenuse. So any right angle triangle is given to us. The first thing that we're going to label is the opposite, adjacent, and the hypotenuse. So I'll draw another right angle triangle. This is the right angle triangle making 90-degree here. So we know that this length is opposite to the 90-degree. So that's the hypotenuse. Now, if I talk about this angle, let's say now this time my angle is a X, which would be here. So opposite to the angle X is called the opposite, where the other side of the right angle triangle is called the adjacent. I'm going to highlight it here now. So this is opposite, this is opposite. Where you see the A, that's for the adjacent, and that's for the adjacent. Where you see H, that's for the hypotenuse, and this is for the hypotenuse as well. The other thing that you see is this S, C, and T. So SC and T represents the angles, which is the sine function. This is the cos function, and that's the tan function. So this is a trigonometry that we use the function sine, cos, and tan to find out the missing length and the angles. We can find out the missing angle and we can find out the missing length. Either way, we can use the trigonometry to find out the length of the angle. We're going to now have a look to the first example. This is that ABC is a right angle triangle. So the first thing we begin is knowing that this is a right angle triangle. Whenever we are finding out any missing length or the angle, which is at the moment we are finding out the length of AB, I'm going to highlight it over here. So this is the length we are finding out. The first thing we're going to do is to label the adjacent, hypotenuse, and the opposite. So opposite to the right angle triangle is the hypotenuse. Opposite to the angle is the opposite. And the other side of a right angle triangle would be the adjacent. Okay, now what I'm going to do the next thing is now what we are finding out and what is given to us. These are the 2 things we should be very clear about. So see that what we are finding out is the opposite. What we have been given is the length is of the hypotenuse. Now I'm going to write down the 3 triangles here, which is so. The other one is of car, and the next one is of toa. I'm going to see that what 2 opposite and hypotenuse. Which one has got the opposite and hypotenuse is this one. So you see that opposite their hypotenuse is here. Whenever we read the triangle, remember that I'm going to draw this one bigger now. So this is so. This line means divide. This is the line of the divide, and this line represents for the multiplication. So this is for divide, this for multiplication. Now we're going to see that how we're going to find out the length of AB. So it is a combination of the hypotenuse and the opposite. We are finding out the length of opposite. So we are finding out the length of opposite. So we're going to write down the opposite is going to be sine, with this stands for sine. Whatever the angle is 38, you multiply it by H. I'm going to see that what's the opposite in our case is the length AB, which we are looking for. Sine 38 would remain as sine 38, and the length of the hypotenuse is 16. I'm going to sub this in here. Now in your calculator, you see that there's a function of the sine. You type sine 38 times by 16, and you're going to come out the length of AB, which would be 9.85. So here we have got the length of the opposite, which is AB, is 9.85. We are writing down to 3 significant figures. So we are writing this down to the 2 decimal places. So now let's have a look to the next example now. Here we see that we have got a right angle triangle, which is 90 degree here. The angle which is given to us is 53. The length of S to T is given as well, which is 14. This says that find out the length of RT. I'm going to highlight RT, so this is what we are finding out. Because this is a right angle triangle, always I label my hypotenuse, adjacent and opposite first. So opposite to the angle is always the opposite side. Opposite to the 90 degree, remember, is the hypotenuse. And the leftover side is the adjacent then. Okay, once we have got all three of them, we always look at what's given to us and what we are looking for. So I'm going to now see that what we are finding out is the adjacent and what's given to us is the opposite. So which one is given us the opposite and the adjacent is basically O and A. So O and A is here. It means what is this function is the tan function. I'm going to write it down here. So this is a tan function. Now to find out the length, we're going to see that we are finding out adjacent. I'm going to put the question mark over here so I would remember that what I'm finding out. So adjacent I'm looking for. So I'm going to write down adjacent, which is equals to RT. As I told that this represents the divide. This line is for the divide. So you do opposite, which opposite is 14 at the moment. You divide by the tan function and the angle. So tan 53. When you divide them together, so you just use the calculator and you're going to get the length of RT, which is going to be, so the length of RT you're going to have is a 10.5 centimeter. Now here we have got now another example where there's a right angle triangle is given. We can see that from here it's making a right angle triangle over here. Calculate the size of the angle ACB. Now this time we are finding out the angle. If it's written as ACB, you always look to what's in the middle. So middle is the C. It means we are finding out the angle C. I'm going to write down the angle X over here. Right, now the next thing we're going to do is to label opposite, hypotenuse and adjacent. Opposite to the 90 degree is the hypotenuse. I'm going to write down hypotenuse here. Opposite to the angle is opposite here. And the other length is the adjacent. So here we have got our three triangles of the SOHCAHTOA. We're going to see that what is given to us and what we are finding out. So I'm going to highlight what's given to us is the hypotenuse and what's given to us is the opposite as well. So using opposite and hypotenuse, the two given things, we're going to find out the angle X. I'm going to see that which one has got the opposite and the hypotenuse. Opposite is here, hypotenuse is here. It means the function that we'll be using is the sine function. So we are finding out the X value from here. We need to be very careful while finding the angle. First thing is, we know that this represents the divide. I'm going to write down as sine X equals to opposite over hypotenuse. So we're going to write it down as opposite over hypotenuse. We're going to write down what's the opposite is. So opposite is 8. Hypotenuse is 10.5. So we'll be having sine X equals to 8 over 10.5. Now, because we are finding out the angle X and we are having a sine over here, so you see that in your calculators, what you have to do to find out the X angle is, you do X equals to, then you press the shift button. You see that is a shift. So I'm writing it down here is the shift and then the sine function. So when you do shift and the sine function, you'll come out with the sine inverse. And then whatever you're having it, you take it, you copy it down. So that would be 8 over 10.5. So you type this and you're going to get the final answer, which would be 49.6. So this is the angle that you're looking for. So you say that this angle is how much? Would be 49.6 degree. Now here is another example. What we are finding out is the angle, and the angle is labeled as a Y. This says that the ramp is 2.1 meter long and 20 centimeter high. The first thing we see that is, this is given to us, the long is in meter and the height is given to us is in centimeter. We're going to write both of them into one unit. So the conversion of the 1 meter to the centimeter would be 100 centimeter. I'm going to convert both the numbers into the meter. So this is 2.1, and to get from the centimeter to the meter, that's equals to 0.2 meter. Okay. Because it's making a right angle triangle and we have to use the trigonometry to find out the angle Y, we're going to label opposite, adjacent and hypotenuse. So opposite to the 90 degree is the hypotenuse, opposite to the angle is opposite, and the other remaining side is the adjacent. Now we see that what triangle we have to use to find out the angle Y. Here we have got the three triangles now. We need to be carefully see that which triangle we'll be using. We always check with what is given to us, so we know what the adjacent is and we know what the opposite is. So which triangle has got opposite and adjacent? So we can see that now here, opposite here, adjacent is here. So the function that we'll be using is the tan function now. So we are finding out the tan y value first of all. Using the tan function now, we know that this line means it's a divide. So we write it down that tan y equals to opposite over adjacent. Then we're going to write it down as tan y equals to, what's the opposite is 0.2, what's the adjacent is 2.1. Remember that because we are finding out the y value and this is a tan y given, it means we need to take this tan to the other side. Doing that, you're going to press the shift button and then 10. So you're going to write it down in your calculator. So in your calculator, you're going to write down shift, tan, and that would give you tan inverse. So to find out the angle y, you do tan inverse of whatever you're having the fraction, which is 0.2 over 2.1. And you get the angle y that would be equals to 5.44. So here you have got the angle y, which is 5.44, and we write it down. This is what we have been looking for. So I would say this is one of the tricky question on applying the trigonometry. We have got a right angle triangle. We can see that this is making a 90 degree. So this length is the hypotenuse, and we cannot decide which one is the opposite or the adjacent because at the moment we don't know about the angles. So ABC is the right angle triangle, AC is 14, angle C is 90 degrees, size of the angle B to the ratio of the size of the angle A is 3:2. We know that the angle in a triangle is add up to 90 degree. If this is a 90 degree, then them two would be the angle A plus the angle B, the sum of them would be another 90 degree. Now what do we know that? The ratio of the angle B to the angle A would be 3:2. So altogether, there are the 5 parts. I'm going to split this 90 into the 5 parts. So one part would be equals to, when you do 90 divide by 5, and each of that would be 18. Now, because angle B has got 3 parts of it, so we do 3 times by 18 would be 54. And angle A has got 2 parts of it, so that would be 2 times by 18, and that would be 36. So angle A is basically 36 here. Angle B is 54. I've written down all the angles now. So what this is that find out the length of AB. So to get the length of AB, basically we are finding out this length AB. So now we have got we can use any of them. We always look to what's given to us. So I'm going to highlight. So we know one of the angle. We know all the 3 angles of the triangle. What's given to us is now, if I'm considering this angle, which is 36. So according to this angle, what I'm going to say that is this is the opposite. And this is the adjacent. Because I'm taking the angle 36, just to avoid any sort of confusion, I'm taking away this one now. So according to the angle 36, this is the opposite. Hypotenuse we know is already, which is opposite to the 90 degree, and adjacent is the other one. So now we're going to see that which trigonometry, which function we're going to use to find out the length of the hypotenuse. So we have got is the adjacent, and hypotenuse we are finding out. So A and H is, you can have A and H from this function, which is this triangle. So we're going to find out now what function we'll be using is the cos function this time now. So we're going to write it down. What we are finding out is the hypotenuse. So remember that what we are finding out is this. This lines means is the divides. So I'm going to write down to find out the hypotenuse, which is AB. We're going to write it down that A, which is the adjacent and which is 14, divide by this function, which is a cos function. So we're going to write down cos 36. So when you do 14 divide by 36, you're going to type this in the calculator, and that would give you 17.3. So we get the length of AB, which would be 17.3. And because it says that, we need to write down the answer to 3 significant figures. So 17.3 is 3 significant figure. The unit is going to be the centimeter. So here's the answer. I hope you have found this video useful in understanding the trigonometry. The application of the trigonometry to find out the unknown length or the missing angle.